Hello my dear children, once again welcome to our physics class. In the previous session we had discussed about projectile motion. It's most important concept in class 11 physics, projectile motion. I hope you might have understood all the different aspects of projectile motion. Today we are going to discuss another important concept and also the last concept of this chapter, circular motion. And you might have studied some basic facts about uniform circular motion in your class 10 physics. Is it an accelerated motion? Yes, it's an accelerated motion because its direction changes continuously with respect to time. So whenever an object is in uniform circular motion, the direction of the object changes continuously at each point on the circular path. Okay, so uniform circular motion is an accelerated motion. Today we are going to discuss about uniform circular motion in detail, and we are going to derive an expression for acceleration of the uniform circular motion and also for the force in uniform circular motion. Also we are going to derive the relationship between linear velocity and angular velocity. Okay, so let's get started with today's session. So children, let's continue with our lesson motion in a plane. As discussed in our introductory video, today we are going to talk about uniform circular motion. So what do you mean by uniform circular motion? When an object follows a circular path at a constant speed, the motion of the object is called uniform circular motion. But at the same time, the speed is constant and the direction of the object changes continuously when it moves along a circular path. At each point of the circular path, the object changes its direction. Hence, velocity of the object will also change because velocity means speed plus direction. So, if any of the speed or direction changes, velocity may change. So here the direction of the object changes as it goes along a circular path. Even if it is moving with a uniform speed, the velocity of the object will also change. Hence, uniform circular motion is also known as accelerated motion. Since there is a change in velocity, we can say that there is an acceleration. Hence, uniform circular motion is an accelerated motion. So, let's try to find out the magnitude and direction of this acceleration. But before moving on to the topic of acceleration in uniform circular motion, we need to know some of the fundamental concepts related to circular motion. So, what do you mean by angular displacement? So consider a circular path like this. Suppose initially the object is at the point A. Let this be the center of the circle. And after some time the object has reached the point B and the object follows this path, that is, it moves in a anti-clockwise direction along the circular path. Now, can you see this angle? So this angle is the angle swept by the object within a time interval t. So that means the object has covered this much angular distance within that time interval. And this angle is denoted by delta theta. And this delta theta itself will be our angular displacement. Okay, so just like linear displacement, this is angular displacement, and this will be our linear displacement. If we join a line from A to B, because A is the initial position, B is the final position, so the linear displacement vector will be always heading from initial to final position. So this vector forms our linear displacement delta S. Okay, so delta theta is the angular displacement and delta S is the linear displacement, and both OA and OB forms the radius vector of this circle. Okay, now What is angular velocity? Angular velocity is denoted by the term omega. See, this is not W, this is omega. So angular velocity is denoted by the symbol omega. And what is linear velocity? Linear velocity, you know, it is denoted by the symbol V. Okay, so we know that linear velocity V is equal to displacement by time, isn't it? So what will be angular velocity? So angular velocity omega will be equal to angular displacement by time. And what is this angular displacement? Angular displacement is delta theta by time delta t. And as this time interval delta t tends to 0, delta theta by delta t can be written as d theta by dt. So this is the expression for angular velocity. Omega is equal to d theta by dt, where d theta is the angular displacement and dt is the time interval. Okay, so what is the expression for angular velocity omega? It is d theta by dt. Now we can come back to this figure. See, in this figure you can apply that arc radius relation, and you know what is arc radius relation? Arc radius relation is arc is equal to, arc radius relation is angle is equal to arc by radius, isn't it? So here what is the angle? Angle is delta theta. So angle delta theta is equal to arc, which is the arc here. This is the arc here, and this is our linear displacement delta s by r, isn't it? So from this you will get delta s is equal to r into delta theta, right? Delta s is equal to r into delta theta. Now divide both sides by delta t. So delta s by delta t is equal to r into delta theta by delta t. And what is delta s by delta t? Delta s by delta t is linear displacement by time. And linear displacement by time is our linear velocity v, equal to r into delta theta by delta t. The delta theta by delta t is our angular velocity omega. So we got the relation linear velocity v is equal to r omega, where v is the linear velocity, r is the radius of that circular motion or circular path described by the object, and omega is the angular velocity. So this expression itself forms the relation between linear velocity v and angular velocity omega. So how will you relate linear velocity v and angular velocity omega? Using this expression v equal to r omega. It's very important concept, my dear children. Linear velocity v is equal to r omega. Okay. Next, what do you mean by time period of this circular motion? So the time period t is nothing. It is the time taken by an object to make one revolution. It is known as the time period. If we consider this as our initial point A, and now the object has covered one round of the circular track, that means one revolution is over. So how much time is taken to complete this one revolution? That forms the time period of the circular motion. And next important term related to the circular motion is frequency, nu. So what do you mean by frequency nu? It is the number of revolutions made in 1 second. Suppose in 1 second the object could complete 3 revolutions. Then what will be the frequency of that object? It will be 3. Or in 1 second, if the object complete 5 revolutions, then what will be the frequency of the object? It will be 5. Okay. So frequency nu means the number of revolutions made in 1 second. And this frequency and time period is related using this expression. Frequency nu is equal to 1 by time period t. That means frequency is the reciprocal of time period t. Okay. And However, during this time, the distance moved by the object is 2 pi r, isn't it? What is the circumference of the circular track? Circumference of the circular track is 2 pi r, and that circumference itself will be the distance moved by the object. Okay, so whenever the object covers one revolution, it has moved a distance of 2 pi r. So what will be the velocity v? Velocity v is equal to 2 pi r. That is the distance divided by time. Time is the time period. Okay. I hope you remember this relation. You already know that velocity v equal to distance by time or displacement by time. And during one round of a circular motion, the object will cover a distance of 2 pi r, and the time taken to complete one revolution is time period t. So this forms distance by time. Okay. And we can write v is equal to 2 pi r. And what is 1 by t? 1 by t is frequency nu. So here instead of 1 by t we can write 2 pi r nu. Okay. So this is the velocity expression in terms of nu. 2 pi r nu. Okay. And we had already studied an expression that v is equal to r omega. Okay, so whenever you compare both the expressions, you will understand, yes, instead of r we have r here, and instead of omega we have 2 pi nu here. So what is the expression for omega? Another expression for omega is omega equal to 2 pi nu, also omega equal to 2 pi by t, because nu is equal to 1 by t. So both are the expressions for omega. Okay, so this is omega equal to 2 pi nu. This is the expression between frequency and angular velocity, and omega equal to 2 pi by t is the expression relating time period and angular velocity. So we had studied three different relationships here, that is linear velocity v equal to r omega, and omega, angular velocity omega is equal to 2 pi nu, where nu is the frequency. Also angular velocity omega equal to 2 pi by t, where t is the time period. Also linear velocity v equal to 2 pi r nu. Okay, so these are the important relations that you should always remember related with the uniform circular motion.